So now let's come straight on into studying document and text search. And we use a couple of existing classes on the web, which I think are really excellent. And we take slides, a lot of the slides from those two sources. Each source is documented. Every slide, if I take it from somewhere else, I list where it came from. So here we have a slide from Technion in Israel, and it basically makes it clear what the challenge is. We have to go and find lots of documents, billions of documents on the web. We have to answer a number of questions per day, and you have to do it in whatever it is, a tenth of a second, or else the user will get unhappy. Or if you're doing this for a particular contractor, that contractor will take his or her search contract and give it to another search vendor. Users do not tend to have very complicated queries. The advantage of that is the good queries are quicker to process. On the other hand, the bad thing about that is it is quite hard to get very restrictive answers. So that's why when you issue a small query to Google or Bing or something, they give you lots and lots of responses. And this you have to get, this is quite important, the most relevant. And these slides will actually discuss what is meant by relevant, because it's not quite so obvious what relevant means, because it really was what the user wants, and quite what they want is not always clear from the simple query. And the blink of an eye is a tenth of a second. So here is a little more detail on the static web. Remember, the web has these various features. It has the actual pages. It has lots of information stored in databases, which are only revealed when you query the database. That's sometimes called the deep web or the hidden web. And this changes. Here's an estimate that a page only lasts a few months. We have each of those pages consists of a set of words, and the estimate here is 10 to 100 million words. You have all sorts of information, text, pictures, audio, video, JavaScript, and what have you. And the quality, of course, varies from truly wonderful, such as some of the best Wikipedia articles, to really total nonsense. And all this stuff is done in many languages. There are lots of duplication, and that's the actual syntactically the same. Then you can get things that are syntactically different but actually mean the same thing. And there's a very complex topology. If you look at the graph you get by taking one page, linking it to another, and which is sort of the basic graph of the web, you get a structure which we'll describe on a later slide. And of course, a lot of the web pages are junk and need to be somehow filtered out. Here's the so-called bow tie structure. This is a reasonably old article, but I don't think it's changed drastically. It comes from looking at this actually comes from 2000. It sort of divides the web into a core part of closely connected parts. You have the input side and the output side, which sort of stretch out. They have little things going out, so-called dendrites. And then there's lots of little isolated, disconnected things with no links to anything else. And that's a sort of classic structure, and one needs to, whatever algorithm one has to cope with this particular structure. Here is, if you look at many things in life, there's a pile of, so here's the number of pages versus the number of links into the page. And here is number of pages, number of output links, and You can see they fall off exponentially with an exponent, which is around 2. And that again is quite old data, but I doubt if it's changed drastically. So this just points out that the number of links to the page falls off quite rapidly, but there is a non-trivial number with high number of links. I should point out that here we actually define in and out. In are where you can go into the page, out of the page, which is pointed to by other pages. So you go out to a page and you come into a page. Those are in and out links. So here we point out again that that you have a pretty small number of words. A word is here a term. A term is a sort of more precise version of a word after you've cleaned up the word and made it in sort of canonical standard form. And sometimes you misspell a term. When you go to a search engine, it will often express doubt, at least about my spelling, and suggest a different query. Usually, the different query is indeed better than what I actually intended. There is a fancy query syntax allowing you to do ands and ors, but most people do not use that query syntax, and it's actually not terribly well documented on the web, on the user interface, presumably because they find that as they're coping with the, they're optimizing for the largest number of people, that the largest number of people don't want to do complicated queries and will get confused, will rather not be even told about the possibility. And this just points out that although we're optimizing for the sort of average person, there's huge variation in what people expect and the quality of their client, whether they're going to scream if they have to browse through 10 pages of search results to find the right answer, and so on. There's a growing importance, of course, of mobile, both tablet and smartphone, and one needs to optimize for the different client platforms, even with the same person feeding in the data. Here's a comment on how many people actually look at the many pages that the search engines give you back. And according to this note here, only 85% look at a single screen. And most of the queries are not changed. They just take what they give, and if they don't give what they want, they don't get it, and they don't requery. So this sort of rather negative statement that we're not actually doing much work when we query the web.